The Weibull distribution. The Weibull distribution is a positive continuous probability distribution. It is very flexible and can mimic multiple different distribution types. It can take shapes close to normal, exponential, different things like that. So it's kind of a chameleon. In civil engineering, it's used in failure analysis, and I have specifically used it in the failure of composite materials. Things that have tails and where the tails are important, the Weibull distribution comes into play frequently. So here is the probability density function, and it's piecewise, but what you can see is that when x is less than 0, it is 0. So it basically doesn't exist. Like I said, it is a positive distribution. Here again, the distribution isn't governed by descriptive statistics. It's governed by a scale parameter and a shape parameter. The Weibull distribution. The Weibull distribution is a positive continuous probability distribution, and it's very flexible and can mimic multiple different distributions. It can be shaped like an exponential distribution. It can also take the form of close to a normal distribution. So it's kind of a chameleon that can mesh between two different things. It's used in civil engineering and in general and failure analysis, and I have specifically used it for the failure of composite materials. It comes into a play when the tail or the diminishing end of the distribution is important. And this comes into play a lot when you're looking at a failure analysis, like when your loads and your resistance overlap and you want to figure out what the failure is where they overlap. You need to pay specific attention to the tails there. The probability distribution function, it is not based on descriptive statistics. It is based on a scale parameter and a shape parameter. It's a piecewise, like other ones here. I'm showing that for any x less than 0, it's 0, basically saying that it is a positive distribution. Here we have the CDF. Again, the CDF only exists for positive values. It is a positive distribution. And since it's based on a scale and shape parameter, we can't just use descriptive statistics. We need to use the maximum likelihood parameters to estimate our shape and scale parameter, alpha and k. Again, we have two equations and two unknowns, but we have to solve these things in unison so that we can get our shape and scale parameters. And I recommend highly using a goal seek or the solver function in Excel to allow us to find the values that we need to fit our data.